We are talking about trigonometry, and we want to use trigonometric ratios to find angle measures in right triangles. And in order to do that, we need to think about our inverse operations. So if we had an equation that was 2x plus 3 equals 7, and we wanted to solve for x, we'd have to use inverse operations. So here we see addition in the equation, and we understand that subtraction is the inverse. So addition and subtraction are inverse operations. So the way that we undo addition is we subtract 3 from both sides of the equation. The 3 cancels on this side, and we take away 3 on this side, so we have 2x is equal to 4. So now we have operation of multiplication, and we know that multiplication and division are inverse operations. So the way that we get rid of multiplication is we divide both sides of the equation by 2. So our 2's cancel, left with 1, so that's going to be 1x, and that's going to be equal to 2. So that's how we solve using inverse operations. Now we go to the trig functions, and we have 3 trig functions right now. We know about the sine, we know about the cosine, and we know about tangent. So each one of these functions have an inverse operation or an inverse function. And so the sine inverse function is sine inverse. And the cosine inverse is cosine inverse. And the tangent inverse is tangent inverse. And we use that in our calculator. And those keys are right above each one of these. So sine is written right here in white, but if we wanted to get sine inverse, we hit second, and sine inverse is written right there in blue. And then we can type the value in that we're trying to find. Cosine inverse is right above cosine, and tangent inverse is right above tangent. So we have a couple examples here. And the reason we talked about the inverse functions is because if we are trying to find the angle, in this case, x is the angle B, we're given the ratio, so we don't need to find the ratio, we need to find the angle. And the way that we do that is by the inverse trig functions. So the first thing we want to do is identify the parts that we have. So here's the right triangle, or the right angle. So that means 16 is the hypotenuse. We're also given that we have the angle right here is labeled as x. So the side away from that, or the side opposite that, so the AC is going to be our opposite side, and 12 is going to be our adjacent side. So the two that we're given, opposite doesn't really help us because we don't know any values there, but we're given hypotenuse and we're given adjacent. So we got to think about which one that is, and that's going to be ca, or cosine. And we can write down the equation as cosine of theta is equal to A over H. So we can substitute in the values that we know. We don't know the cosine. So cosine, or we don't know the angle theta, so cosine of theta. And I'm going to leave a little bit of room here, specifically because of what we have to do in order to solve to get theta by itself. Our A value is 12, and our H value is 16. So now we have it all set up. Now we want to solve. So we have theta over here, or our x variable right here, and we want to get that by itself. So just like when we had addition, to get rid of addition, we did the inverse operation on that side. And just like when we had multiplication, we did the inverse operation to cancel it. We have the cosine, so we have to multiply both sides by the cosine inverse, or the inverse cosine. So I'm going to put this whole side in parentheses, and I'm going to multiply that by the cosine inverse. And whatever we do on the left side, we have to do on the right side. Cosine inverse of everything on that side of the equation. So our cosine inverse cancels the cosine, and then we're left with just theta, or just our angle x. And this is theta right here. That's the angle we're trying to find. Now we can use our calculator to get the value there. And so because it's cosine inverse is in blue, so we're going to hit second cosine, which gives us cosine inverse. 12 divided by 16, and that is equal to approximately 41.4 degrees, because now we've calculated the angle. So theta is approximately equal to, because it's not exact, it's rounded, 41.4 degrees. I have another example over here, number 8. Again, we want to identify the information that we have. So here's the right angle. So this side over here is the hypotenuse. And then we have our angle, which is right here, is K. So the side opposite, we have 7 is the opposite side, and 3.3 is the adjacent side. So we got to use the trig function that has O and A in it. So that is going to be TOA. So we're talking about tangent of theta is equal to the ratio of O over A, or opposite over adjacent. We can substitute in the values that we're talking about. I'm going to move this tangent a little bit away here. So it's tangent of K, we don't know what that value is, excuse me, is equal to, and I'm going to leave a little space here because of the way that we're going to have to solve this. Opposite is 7, and adjacent is 3.3. And now we want to undo the tangent, or we want to get the tangent away from the K. So what we're going to do is we are going to multiply both sides by the tangent inverse. We put that whole thing in parentheses, that whole fraction. So tangent inverse and tangent cancel, and we're left with just K. And now we can plug this in our calculator. We're talking about the inverse tangent, so we're going to hit second tangent. Then we're going to get 7 divided by 3.3, parentheses, and we get our answer, and that should be approximately, not equal to, but approximately, so we make that a wavy equal sign, 64.8 degrees. Now if you type this in your calculator exactly as it is here and you don't get 64.8 degrees, then remember, go to mode and check to make sure that degrees is highlighted and not radians.